Section 2.4 Atomic Weights. Atoms are small pieces of matter, so they have mass. In this section, we discuss the mass scale used for atoms and introduce the concept of atomic weights. The atomic mass scale. Scientists in the 19th century were aware that atoms of different elements have different masses. They found, for example, that each 100 grams of water contains 11.1 grams of hydrogen and 88.9 grams of oxygen. Thus, water contains an 88.9 to 11.1, or 8 times as much oxygen by mass as hydrogen. One scientist understood that water contains 2 hydrogen atoms for each oxygen atom. They concluded that an oxygen atom must have 2 times 8, or 16 times as much mass as the hydrogen atom. Hydrogen, the lightest atom, was arbitrarily assigned the relative mass of 1 number of units, or no units. Atomic masses of other elements were at first determined to receive this value. Thus, oxygen was assigned an atomic mass of 16. Today, we can determine the mass of individual atoms with a high degree of accuracy. For example, we know that a hydrogen atom has a mass of 1.6735 times 10 to the negative 24 grams, and that the oxygen atom has a mass of 2.6560 times 10 to the 23 grams. As we noted in section 2.3, it's convenient to use the atomic mass unit when dealing with these extremely small masses. 1 AMU equals 1.66054 times 10 to the negative 24 grams, and 1 gram equals 6.02214 times 10 to the 23rd AMUs. The atomic mass unit is presently defined by assigning the mass of exactly 12 AMUs to an atom of the carbon-12 isotope of carbon. In these units, a hydrogen atom has the mass of 1.0078 AMU, and an oxygen atom has a mass of 15.9949 AMU. Atomic weight. Most elements occur in nature as a mixture of isotopes. We can determine the average atomic mass of an element, usually called that element's atomic weight, by using the masses of its isotopes and their relative abundances. The atomic weight is the sum of all of the isotope masses times their fractional isotope abundance over all the isotopes of an element. Naturally occurring carbon, for example, is composed of 98.93% carbon-12, 1.07% carbon-13. The masses of these isotopes of 12 AMU exactly and 13.00335 AMU respectively, making the atomic weight of carbon 0.9893, that's the percentage, times 12 AMU plus 0.0107, that's 1.07%, times 13.00335 AMU, averages to 12.01 AMU. The atomic weights of the element are listed in both the periodic table and the table of elements inside the front cover of the text.